Hi everyone, this is Mrs. Guzman. These are your notes for properties of waves. All waves exhibit these four properties that we'll discuss in these notes today. The first one is interference, reflection, refraction, and diffraction. Interference occurs when two or more waves interact with each other. We have two types that we'll discuss. The first one is constructive. So this happens when wave displacements are in the same direction. So as we watch the animation, we see two waves approach each other. They interact and then each one continues on their way. So they pass through one another. At the point where they meet, we see the addition of both their amplitudes. So the net displacement will be the sum, the addition of both of their amplitudes together. Destructive occurs when two waves of opposite amplitudes meet. So if we have just a regular wave that's not moving in this animation and one that is, we can see when opposite displacements or opposite amplitudes meet that there is no wave present. So the superposition principle states that the net displacement is the sum of the individual displacements. So if the amplitudes are in the same direction, we would add them together. If they are in the opposite direction, we still add them together, but one of them would have a negative displacement or a negative amplitude. So basically, you're just combining the amplitudes of waves when they interact with one another. Reflection occurs when waves bounce off some type of boundary. So we have two types of boundaries that we'll see. A fixed boundary, as you see in this animation, is not able to move. So as the wave hits the fixed boundary, you see in this example that it changes direction. So where we have a positive amplitude approach the boundary, it flips to the other side and continues on its way. If we have reflection from what's called a soft boundary, you see that there's a big difference in how the reflected wave behaves. So the fixed boundary, or the soft boundary is able to move and causes the wave to reflect in the same direction as what's called the incident wave. That's the one that approaches the boundary. Refraction happens when a wave bends as it enters a new medium. So speed and wavelength are going to change. You'll see this if you have an ocean wave or some type of water wave occurring in deep water, and then the depth of that lake or ocean changes and the wave now has to travel through shallower water. And then diffraction happens when we have a change in direction as the waves pass through an opening or around a barrier. This is commonly thought of a lot as an example for sound. So you can hear sound waves even if you cannot see the person. Sound will bend through doorways, bend around walls, so that you can still hear sound even though you're not in the direct line of sight of the source of that sound.